In this video, we will discuss the kinds of microeconomic data that are available and potential sources of data for your research paper. We will also look at how AI tools are changing the way one may approach it. In any empirical analysis, we will begin with the relationship or economic question of interest. Question in economic theory will use a theoretical framework to derive testable hypotheses. In order to test our hypotheses, we need to find appropriate data that includes the variables we're interested in. Sometimes this will entail finding more than one data set. For example, one data set may have health information and another has minimum wage laws, in which case we need a way to combine or merge our data together. Given our data and hypotheses we developed, we can now attempt to test our hypothesis or estimate the relationship of interest. Finally, we will present our results using a combination of tables, figures, and text. Finding the right data is as much of an art as a science. It is a good idea to begin with your general research area and consider the data sources related papers chose to use. This is an area where literature review can be very helpful by enabling you to identify relevant papers more easily. For many research topics, one or more government agencies are closely associated with that topic. The CDC, the EPA, the Bureau of Labor Statistics, HUD, or the National Center for Education Statistics are just a few examples of relevant government agencies, depending upon your research. AI tools can also be useful to find data since they have collected vast amounts of information from millions of journal articles. As an example, I used ChatGPT and prompted it with, "Can you suggest potential data sets for a research paper on the relationship between the minimum wage and health?" Here's a list of the data sets that I came up with. NHIS, National Health Interview Survey, BRFIS, Behavioral Risk Factor Surveillance Survey, MEPS, or the Medical Expenditure Panel Survey, Vital Statistics Mortality Data, the NLSY, National Longitudinal Study of Youth, and state-level minimum wage data. In this case, all of these data sets exist, but sometimes it will make up a data set, so you need to check if a data set has what you need. About the data we need to keep three key features in mind. First, we need our desired variables. We want our outcome variable of interest and also the independent variable of interest. Now, these two variables sometimes come from different data sets, but then there need to be variables that will allow us to combine the two data sets. Using our minimum wage and health example, we would want the data set with a health outcome and identifiers for state and year so that we can merge on state and year specific minimum wages. This brings us to our second issue for data set. We need the data to cover a relevant time period, typically several years before and after a policy change. Third, most methods in economics for covering causal effects require an untreated comparison group, so we'll need data on both treated and untreated units. Finally, sometimes we just can't find the right data. So what do we do then? We really only have two choices. First, we can find a suitable proxy variable for our analysis. What is a proxy variable? It's a variable that tracks the true outcome we're interested in, even if it's imperfect. The relationship between the proxy variable and the truth needs to be consistent over time and across space so that any errors in the proxy are not correlated with the independent variable. Our second choice, which is more common, is to adjust or change the research question so you have the right data. Now, there are other sources of data out there as well, but some are not. So tables and graphs that appear in journal articles are not data sources, and you should not be using them as such. I'll provide a list of additional sources, however, in Canvas. Let's now talk about different types of data. Cross-sectional data is one of the most basic kinds of data. This is a snapshot of time across a group of people, states, etc. Time series data works in the time dimension and is a series of measurements on a single person or state over time. Repeated cross-sections is a series of cross-sections for each time period. Panel data is a set of time series for the same people or states. This is an example of cross-sectional data. We have an identifier for each unit, and then data relevant to each unit. Here's an example of time series data. These data are essentially the opposite of cross-sectional data. We have an indicator for time, and then data for each point in time. Now we'll turn to two different ways to construct data that combine features of both cross-sectional and time series data. First, we look at repeated cross-sectional data. These data are repeated cross-sections or a time series of cross-sections. For each time period, and then for each time period, we have a number of observations with data for each observation. But these observations do not relate to each other over time. That also makes them repeated cross-sections versus our next example, panel data. So this is the other way to combine cross-sectional and time series data, is to think of this as a cross-section of time series rather than as a time series of cross-sections. So for these data, we observe the same unit over time. So we have a unit or person identifier, a time period identifier that varies within each unit, and then here data for each person year. There are other important nuances about data that we should address. First, data can be adjusted for regular seasonal trends. Ice cream sales, for example, are systematically higher in the summer than in the winter. So a high winter value and a high summer value mean two different things. Seasonal adjustment removes this regular pattern and would, with that example, convert them into an abnormally high winter value and a normal summer value. This also happens with other things like jobs, where there's a regular spike in employment among 16 to 21-year-olds over the summer because they're out of school. The second issue is that the value of a dollar changes over time in a process we call inflation. As a result, $1 today is worth more than $1 tomorrow. Here's an example using employment, which shows a regular increase in summer jobs for younger workers. When we think about inflation, we need to keep two different values in mind. The nominal value is the raw value or raw dollar amount from when the data were collected. The real value converts nominal values into a value that's normalized for changes in inflation or the value of money over time. We can see this effect by looking at the trend in tuition across public four-year universities. Here you see that it started relatively low at about $500 and rose to a little over $10,000 by the end of this time period. In order to inflation adjust our tuition data, we need to get our inflation values. This requires we specify a base year, which is typically arbitrary, choose a price index, and this graph here shows the consumer price index since 2001, which has been steadily inching upward. And you can find these data through the St. Louis Federal Reserve FRED database. Then we need to apply the index using a transformation that multiplies the nominal value by the ratio of the base year index to the index at the time of data collection. So to get the real value using base year of 2020 in 2015, we would take the nominal 2015 value, multiply it by the index in 2020, divided by the index in 2015. Having done that, we can now see that the increase in tuition over the past several years has been much less dramatic than it first appeared, since inflation adjusted or real tuition in academic one is over $2,000 instead of a little over $500.